All right, guys, welcome back. All right, so we are continuing this lesson on from the previous example, which was the horizontal and vertical reflection. So now we're talking about the horizontal and vertical stretches. Okay, so we're going to take a quick look at this Desmos screen. Okay, so just different function of their last one over here. I'm just going to change this to, there we go. So here's our function. So we have a parabola, but I've kind of limited it only from the x values of -2 to 3. So that's why it kind of starts here at x equals -2 and it ends here at x equals 3. So this is kind of a restricted parabola here. So what we're doing here is we're looking at this red function over here, which we call g of x. So what g of x is doing is we're putting an a value out in front. What we saw in the last section, that if I have a negative out in front, so in other words, this is a -1, my graph is going to be this. Okay, so what we're seeing here is we're going to see a reflection in the x-axis. So here's your x-axis. The blue graph gets reflected down to the red graph over here. Okay, now, so this is when we have a -1, or just like a negative a value here. So what happens if I have something other than that? Well, if I make an a value of 2, what happens? What we're looking at here is, let's compare this point to this point, okay? So first of all, this -2 and this -2 are remaining the same. Okay, so in other words, the x values haven't changed, but the y values is 4, now it's 8, okay? The way we're gonna look at this is from 4 to 8, if I multiply this 4 by this a value of 2, it's gonna give me this new value of 8. If this guy is 3, 9, if I multiply 9 times 2, it gives me 18. The way we describe this transformation is we say that this guy has been it's been stretched by a factor of 2 in the x-axis. So again, here's our x-axis, or sometimes we say it's from the x-axis. So if this guy is 9 above the x-axis, now it gets stretched, now it's 18 above it. I've doubled this distance over here. This guy was 4 above the x-axis. Now it's been stretched to 8 above the x-axis, okay? If I make this guy a value of 3, same idea. I've just multiplied my y values by 3. 4 times 3 is 12. 9 times 3 is 27, okay? If I make my a value 1.5, 4 times 1.5 is 6. 9 times 1.5 is 13.5, okay? So the point we're trying to get at, if we make this a value in a function over here, we're taking our original y value and multiplying it by whatever a is. So if a is a negative value, okay, so in this case we have two transformations. We have a vertical stretch, or a stretch in the x-axis by a factor of 2, but we also have a reflection in the x-axis as well. So looking at the points here, my a value is now -2. This type of transformation multiplies the y values by whatever this a value is. So if y was 4 times -2, now it's -8. Y was 9 times -2, now it's going to be -18 over here. That's what this a value of -2 is going to do. Okay. All right. So two similarities and two differences. Okay, so similarities, what we say? I could say both graphs have the same domain. So there's one similarity. The same domain. Okay. I'm also going to say, think at this point here, 0, 0. Well, if my y value is 0 and I multiply it by 2, it's still 0. Both graphs have the same vertex of 0, 0. Okay, so here are two similarities here. Okay, what are two differences here? the graphs have different ranges. So in other words, for y equals f of x, the range goes from 0 to 9. For y equals 2f of x, the range goes from 0 to 4.5. Okay, so the ranges are different. Okay, I'm going to say the y values of the blue graph are double the y values of the red graph. Okay, so there's are some similarities and differences that we can talk about here. Okay, for the next part here, y equals f of x becomes y equals a f of x. We say that y equals f of x has been vertically stretched about the x-axis by a factor of the absolute value of a. Now, the reason we say this, a stretch is always going to be a positive value, but if a is negative, that means there's also going to be a vertical reflection in the x-axis. Our mapping notation goes xy, which is any point on our original, becomes x ay. Okay, so we're multiplying this y value by whatever this a value is here, and that's going to be our new point on the graph. Okay, so given our graph of y equals f of x, we're going to scratch a of x, which is y, which is 3 f of x. So this guy over here, what's this 3 do? Let's get our good proper terminology here. This is a vertical stretch by a factor of 3. And I'm going to say about the x-axis. Okay, so in other words, what we're doing here, we are multiplying y values by 3. Okay, so I got that over here. So when we're describing the transformations, that's what I'm doing in this step right over here. This is for a of x. Okay, so in other words, what happened at this point? 4 becomes 412. My y value over here. 2 0.5 becomes 2 1.5. Okay, so that was going to be, I think these are going to make by 2 4 6 8. So tougher to see, but it's about right here. This point, 0 times 3 stays the same. This is going to be an invariant point. This point stays here. Negative 13.5 times 3 is going to be negative 40.5, which is way down over here. Okay, so this graph is going to look like this. Okay, and this graph definitely stops here and here. This is a of x. Okay, all right, what's 1/2 f of x going to be? So this is going to be a vertical stretch. I'm going to say about the x-axis by a factor of 1/2. This means we multiply y values by 1/2. Okay, so 4 becomes 4 This guy goes even closer there. This guy stays here. This guy is half there. Half of negative 13.5 is negative 6.75, which would be about right here. Okay, so this graph, same exact shape, but it's just been stretched by a factor of 1/2. And this is our b of x graph. Okay. Example 3. So the domain and range of y equals f of x goes from -5 to 7, and y is greater than or equal to 12. What are the domain and range of y equals -3, f of x plus 4? Okay, so this is kind of we're dealing with a couple different transformations over here. This is a vertical stretch by 3 and reflection in y-axis. This is what we talked about in the previous section, which is going to be a horizontal translation of -4 units. So it's going to be a shift 4 left. Okay, so what's that going to do? First of all, this vertical stretch is going to have no effect on the x values. It's only going to affect the y values over here. Got a mistake. Sorry, this is reflection in the x-axis, not the y-axis. But this horizontal translation will affect these guys over here. So if this domain goes from -5 to 7, and I'm going 4 units to the left, my new domain is going to be -5 minus 4 is -9. 7 minus 4 is 3. So here's my set notation for this. Okay, my range. Okay, so if it was bigger than or equal to 12, if I multiply it by 3, it's going to be y is greater than or equal to 36. But I reflect it in the y-axis. Now it's going to be -36, but if it was bigger than 36 and reflected, now it's going to be smaller than -36. So my range is going to be y is less than or equal to -36, where y is a real one. Okay, so for example, if this is 12 and the graph is going up like this, well, if I reflect it and stretch it, it's going to be way down here. Now it's going to be going down like that. So that's why this graph is, so this is -36 y value here. The graph is, if it was going up, because it was greater than 12, now it's going to be going down less than -36 over here. Okay. So the graph of y equals f of x passes through the point, point 6, 8. If the graph of y equals a f of x passes through the point 6, -6, determine the value of a. So the idea that we're doing here is that x comma y becomes x comma ay. Okay, so this is going to be so this a is a vertical stretch, or that means we're multiplying our y values by a. Okay, so in other words, if this point over here, 6 comma 8, okay, well, the 6 stays the same, but I'm multiplying this 8 value here by a. Well, what's this new point? A times 8 is really equal to -6. Okay, so how am I going to get a over here? Well, I'm just going to do a bit of algebra and divide by 8. And the fraction 6 over 8 reduces to -3 over 4. Okay, so my a value for this question is going to be -3 over 4, and that's how that works. Okay, so we did examples similar to this one over here. We have f of x is x cubed minus 6x squared plus 3x plus 10. Determine the invariant point if y equals f of -x. So this is a reflection in the y-axis. So this is a horizontal reflection in the y-axis. Therefore, the y-intercepts are invariant. Okay, so how to figure out y-intercept? Well, we just make x equal to 0. So therefore, set x equal to 0. So this is going to be f at 0 equals 0 cubed minus 6 times 0 squared plus 3 times 0 plus 10. 0, 0, 0 equals 10. So 0, comma 10 is invariant. Okay, so this over here is a reflection in x-axis and a stretch in x-axis by factor of 2. So those are the transformations that happen. Therefore, the x-intercepts are invariant. Therefore, set y equal to 0. So we need to go 0 equal x cubed minus 6x squared plus 3x plus 10. Okay, we just learned in the polynomials unit, okay, how to be able to factor and solve these types of questions over here. Okay, so how are we going to do that? Our potential integral zeros are going to be the factors of 10, are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. I have a feeling negative 1 is going to work out here. Negative 1 cubed minus 6 times negative 1 squared. So guys, if you're watching this video and you haven't done this unit yet, and I think most people in Math 30 have, I teach at Scarlet and we kind of teach it this way where we teach this unit first. Don't worry about this method over here. You'll learn it in chapter 3 in a bit, okay? So negative 1 minus 6 is negative 7, minus 3 is negative 10, plus 10 equals 0. So f at negative 1 equals 0. Therefore, x plus 1 is a factor. Okay, now our synthetic division step. So the 1 comes down. Again, guys, if this is, guys, many people watching this video probably have not learned this stuff yet, but you will in the next unit. So we get 0 equals x plus 1, x squared minus 7x plus 10, because that's what this represents over here. This is x squared minus 7x plus 10. This guy factors further. So this is still a quadratic here. So we get 0 equals x plus 1, x minus 5, x minus 2. So therefore, x equals negative 1, 5, 2. We should have 3 invariant points. That means negative 1, 0, 5, 0, and 2, 0 are invariant points. Okay. Guys, for part C, I'm going to ask you guys to go ahead and try graphing these guys and see if these are in fact going to be our invariant points. Okay, so what we're going to see here is I've given you a graph where we have our original one is blue and the purple graph is our new one f of 1/2 x. So if I have the point 16, 4, this guy is 32, 4. 9, 3 becomes 18, 3. 4, 2 becomes 8, 2. 1, 1 becomes 2, 1. What we're trying to get is, if we have a 1/2 here, and I'm going from the blue graph to the purple graph, well, how do we get from 16 to 32? I'm multiplying by 2. From 9 to 18, I'm multiplying by 2. From 4 to 8, I'm multiplying by 2. From 1 to 2, I'm multiplying by 2 as well. Okay, let's take a look at the Desmos screen here. Okay, so what we have here, okay, so here's our graph, y f of x equals square root of x, and so we talked about this function earlier on, okay? So now what we have is what happens if we have this b value here, okay? So if we look here, if I start making b 2, if this is my original, I've actually what I've done is I've gone 16 times 1/2 to get to 8. So what we have here is this is what we call a horizontal stretch. It was 16, now it's 8. That comes by multiplying this guy by half. It was 9, now it's 4.5. 9 times 1/2. 4 times 1/2 is 2. 1 times a half is 0.5. If I make b 0.5, like we saw in the previous example on the PowerPoint presentation there, if my b value is 1/2, which is 0.5, that means I'm multiplying by 2, okay? So something that's kind of definitely a little bit stranger is going on from this graph to this graph over here, right? So it almost seems backwards, right? If I make a b value of 2, that means I'm actually multiplying by a half my x values. If I have a b value of 0.25, which is the same thing as 1/4, it means I'm actually multiplying by 4, okay? So this is how these type of graphs work over here. So in this one, we'll see that if we have y equals f of x becomes y equals f of 1/2 x, what's happening with the mapping notation here? My original point, this x value gets doubled, okay? And we have a special name. If 1/2 becomes 2/1, these guys here are what we call reciprocals, okay? So what we're trying to get at here, the stretch factor, which is 2, I've doubled my x values from here to here, is going to be the reciprocal of this b value here, and that's how we do these guys. Okay, quick over, very similar to what we did in the last one here. So if I have square root of x equals 0, okay, so square, that means x equals 0. Square, x equals 1. So nothing too tricky here. We're just solving this one for x. Now, if I have 1/2 x, and I square both sides, if I square it, now I get 1/2 x equals 0 times 2 times 2 is still x equals 0. Square, I get 1/2 x equals 1. So if I want to get x by itself, what I need to do is I need to multiply both sides by 2, like that. So 1 times 2 is 2. Same thing here. If I square, I get 1/2 x equals 4. If I multiply times 2, 4 times 2 is 8. Square, I get 1/2 x equals 9. So the reason why we're multiplying by 2, it's in this step right over here, right? That's why this x actually gets doubled. So it was 9, now it's 18. Square, 1/2 x equals 16 times 2, that means x equals 32, like this, okay? So it's a little bit tricky. So why does this 1/2 x, why does this 1/2 actually give us a doubled x value? It's because of this process over here, okay? So hopefully this kind of makes sense. So little general notes here. When y equals f of x becomes y equals f of bx, we say that y equals f of bx has been horizontally stretched about the y-axis by a factor of 1 over b. So remember, with a b value, the reciprocal is going to be the stretch factor. If b is less than 0, there's also a reflection in the y-axis. Our mapping notation is xy becomes 1 over b times x times y. All right, so we're going to describe these transformations over here. Okay, so in this case, this is the 3, which is put out in front of this x, means a vertical stretch in the x-axis or about the x-axis by a factor of 3. Okay, that's what this, so if it's outside the function like this, it's going to be a vertical stretch. Now, what's this 1/4 do? Okay, well, what's the reciprocal of 1 over 4? 4 over 1 is the reciprocal of 1/4. Okay, so what this one's saying is we have a horizontal stretch about about the y-axis by a factor of 4. Okay, so here's the thing. If this over here, which we call the b value, the b value is 1/4. The stretch factor is the reciprocal, which is 4. Okay, so that's what this means here. Back to this guy. So 5, 1/5 is the reciprocal of 5. So for this case, we have a horizontal stretch by a factor of 1/5. And again, this is about the y-axis. Okay, so it's a little bit confusing. So if the b value is inside the brackets like they are here, that means the stretch factor is the reciprocal of the b value. Okay, so let's graph over here, y equals f of 1/3 x. So what's this mean here? This means a horizontal stretch about y-axis by factor. The reciprocal of 1/3 is 3. Okay, so this means what we're doing is that xy becomes 3xy. Okay, in other words, I'm tripling all my x values. Negative 2, 5 becomes negative 6, 5. 0, 3, this guy stays the same, so this is a y-intercept. It's going to be invariant. So if I'm stretching it in the y-axis, any y-intercept is going to be an invariant point here. 1, 2, getting tripled becomes 3, 2. 2, 3 becomes 6, 3. 4, negative 1 becomes 12, negative 1 here. Okay, so this graph is going to look like, I'm going to have a straight line through here like this, and then I'm going to have a curved part like that. Okay, what does this guy do? This is going to be a horizontal stretch about the y-axis by a factor of 1/2. In other words, we're multiplying all the x's by 1/2. Negative 2, 5 becomes negative 1, 5. 0, 3 stays the same, it's invariant. 1, 2 becomes a half 2. 2, 3 becomes 1, 3. 4, negative 1 becomes 2, negative 1. This graph looks like this and like that. Okay, so this is going to be the stretch over there. So guys, I know this is definitely a kind of a confusing type topic over here, especially like, so here is the stretch factor. So our mapping notation for this guy was looking like this. So this is our original. We are multiplying our x's by 1/2. Okay, so given that g of x equals negative 4, f of negative 6x, and a negative 24, 14 is on the graph of y equals f of x, determine the coordinates of a prime if a prime is the image point of a on g of x. Okay, so what's our mapping notation doing here? Xy goes to this, the reciprocal of 6 is 1/6. Therefore, we have negative 1/6 x, and we have negative 4y. So we're multiplying our y by this value, and our x's by the reciprocal of this value here. Okay, so therefore, what are we doing to this point? We have negative 1/6. Our x value is negative 24. like this, comma, -4 times our y value of 14. -1/6 times 24 is 4. -4 times 14 is -56. Okay, so here's going to be our coordinates for point A prime. Example 10. The graph of y equals f of x is transformed to the graph of g of x equals a f of bx. If 34 is on y equals f of x, 10, -40 is the image point on y equals g of x. Determine the values of a and b. Okay, so let's come back to this guy. What's this telling us over here? Is that xy becomes 1 over bx a y. Okay, now this is our original. Okay, so we have 1 over b times 30, and we have a times 4 equals 10, -40. Okay, so we need to figure out this gets mapped to this guy over here, and this gets mapped to this -40 here. So if I go 1 over b times 30 equals 10. Okay, well, I'm just going to multiply both sides by b like this. So I get 30 equals 10b, divide by 10, divide by 10. That means I get 3 equals b. Okay, my b value is 3. Done. Over here, I have a times 4 equals -40. If I divide both sides by 4, I get a equals -10. Okay, so over here, what do we get? We get a comma b equals -10 comma 3. I'm going to write this as an ordered pair like this, and my answer is done like that. All right, guys, I know this topic over here, it takes a lot of practice. Okay, so please make sure that you guys are keeping up with your textbook questions like that, and make sure that you're coming to see me if you have any questions based off that. Okay, see you in the next video. Bye-bye.